probably the main statistic that you hear when you listen to the media is related to percent increase or decrease. All right, we're hearing things like that all the time. Like, in this state, the COVID cases are up 20% compared to where they were last week, or, deaths are down by 5%, hospitalizations are up by 30%, right? And we hear these things all the time. And I want to take a deep dive on what that really means and how we interpret when we hear those types of statements being made in the media. So first of all, let me give you the formula for percent increase or decrease. All right, so first of all, it's the amount of increase or decrease. Okay, so I'm just going to put amount of either up or down. Amount of increase or decrease. Maybe you want to write out the words increase or decrease. It's harder for me with my little stencil here. Okay, amount of increase or decrease divided by the original value. Right, so starting value. So the original value or the starting value. Okay, so we are always comparing to where we started. All right, so let's take a look at number 7 and just see if we can use our formula. Okay, so percent decrease. Okay, so we have to find the amount of decrease. Okay, and percent is always positive, right? So we're always going to subtract the smaller number from the larger number so that we always have a positive up in the numerator. Okay, and then when we decide what number to divide by, we are always dividing by the original value. Where we started is what we divide by, because that's what we're comparing to. We're comparing to where we started. Okay, so crunch these numbers, and I had said to round off in a way that makes sense. So if you just divided this on your calculator, you got this. So let's say a way that makes sense would be to call this, move our decimal over 2 places and call this 17.8. I'm sorry, I just looked at the wrong problem. The final answer is 0.0835, right? So to round this off in a way that makes sense, let's call that 8.4%. Okay, so pause the video and try number 8. Okay, and if you're back, that was a 40% increase, 40-cent increase, sorry, divided by where we started. And that's why I was given that 17.8 answer in the last problem. I had looked at this one by mistake. So let's round this off in a way that makes sense and call this 17.8%. Okay, number 9, I hope we can do 10% in our head, right? 10% of 20 would be 2. Okay, so if I have a club with 20 members who has 2 people join, okay, so it goes from 20 up to 22. So we have 2 people that have added divided by 20. But I hope you could do that in your head and recognize that that is a 10% increase. Okay, but then next week 2 people leave. Right? So wouldn't that be, 2 people are 10%. So then the next week, 2 people leave. Shouldn't that be 10% also? Okay, so think about that for a minute. Is the answer to the second part of this 10%? Why or why not? And here's where I regret not being able to be in class, because I would want to discuss this and hear what people say. Okay, but anyway, the club has now gone up to 22, right? We are now comparing to 22 people. So 2 out of 22 is a different percentage than 2 out of 20. So it all depends, the percent increase all depends on this bottom number. And that's where this statistic can sometimes become very misleading, right? Because, well, we'll look at this. I don't want to get ahead of myself. We'll look at this in the next example. Actually, number 10 is a perfect example to show this. It all depends on the base that you start with. All right, so it's not about a numeric increase, but rather the percentage compared to the base that you start with. Okay, so this would be 9%. All right, now in number 10, oops, let's go back up a little bit. Okay, so 2 churches report a 15% growth rate in 1 year, because I can remember being in church, and I remember our pastor, you know, being very proud of this and said, we are the fastest growing church in our denomination. We are the fastest growing church in New York State. And I remember thinking, okay, we're kind of a small church, right? It's easier for us to show a large percentage growth in 1 year than it would be for some of these churches that have, like, you know, 1,000 or 2,000 members. All right, so that's exactly what I'm going to illustrate here. 2 churches. So we have church A and then we have church B. Okay, so they're reporting a 15% increase in 1 year. Okay, so if I do this times 15% versus doing this times 15%. So both churches showed the same rate of increase, right? 15%. But in this smaller church, they only added 10 members. Sorry, I'm trying to find my work on my paper. They only added 10 members. Okay, it came out to actually 9.75, right? But we've got to round off in a way that makes sense. So they added 10 members. But over here in Church B, they needed to add 180 members to show the same percentage increase. So the bigger base we started with, the larger of a numeric increase we need to show the same percentage increase. So that's why all this stuff with the coronavirus, when coronavirus cases were low, you know, there were only a few, and we showed a 50% increase, that wasn't as catastrophic as when coronavirus cases are like out of control, right? And then we talk about a 50% increase, right? That 50% increase is 50% of a larger base, right? Which makes it much more significant. For example, if 2 people are sick, right? And then the next week, 3 people have it, 3 people are sick, what percent increase is that? Right? I went up by 1 and compared it to 2, right? So going from 2 sick people to 3 sick people is actually a 50% increase. Okay, so that's how misleading this statistic can be. So moving on to the next example. And here's an example about the 50% increase. So why don't you pause the video and try 12 and 14. I'll record the answers, and then if you've got them right, you can stop the video. This one number here, 13, this is what you're going to submit for your February 5th participation. Okay, so you're going to compute this exercise and turn this in. Okay, so pause the video now. Okay, so if you're back, First County had a numeric increase of 150 people, right? There were 150 additional sick people for a total of 450. Okay, but having that larger base, right? If I went up by, so here I actually had to do the percentage increase. If I went up by $650 compared to the 2,100, right? Even though I added so many more cases than the other county, my percentage increase is lower. Okay, 45%. All right, and so why does this happen? Explain this in your own words. So I hope you said something here about, the bigger the base, right? The more it would take numerically to show the same percentage increase. Okay, it all depends on the number that you started with. And then in number 14, this was a question I had at the whole what are we going to learn now? I hope you realize that the blouse would sell for $15. Okay, if not, hang out for another minute. If you said $15, you're done and go ahead and stop the video. Okay, so if you didn't get this, she would mark the blouse up by 50%. All right, I hope we can do this in our heads. 50% of 20 is 10, right? So adding the 50% would get you to $30. Okay, then the blouse doesn't sell. Okay, so this time the 50% is applied to a different base, which means over here the 50% was $10, but if I apply 50% to a different base, now that 50% off is $15. Okay, and that's how we get then the 30 minus 15 to get that as a selling price. So thanks for hanging in there all the way till the end.